Hi all. So we've got our last little section in this factorising section is completing the square. And we did this last topic, so it will probably be quite a bit of review for you. But when we're graphing quadratics, it's useful to create perfect squares with your quadratics. We've talked about perfect squares already. They're of this form here. Ax squared plus 2ab plus b squared, that factorises to be a plus b all squared. And likewise, when we've got the minus sign, that factorises to be a minus b all squared. Now we're going to talk about why this is so useful, but if we get quadratics of the form y equals a bracket x take h all squared plus k, that's going to tell us a geometric property of our quadratic, which is going to enable us to graph it. So when we complete the square, we're just creating a scenario where a perfect square exists. We don't have a perfect square, but we create that scenario. To do this, as you remember, you'll take the coefficient of x and square it. So you might want to use the word select so you don't get it confused with the actual operation of taking. So select the coefficient of x and square it, add this and take it away. And the reason we do this is because if we just added in the coefficient of x divided by 2 and squared, we'd be actually changing the quadratic. But if we take it away as well, then we're fine, it's the same quadratic. Then the original squared term, the term containing x, and the new squared term will form the perfect square. So again, as always, it's easiest to look at this when we look at an example. So we've got here the example of x squared take 5x plus 9. Y equals that. So if we do what we said we'd do, we'd select the coefficient of x. The coefficient of the x is, in this case, negative 5. So I'm going to do x squared take 5x. Now I'm going to put my second term where it says add this and take it away. I'm going to put that next to the 5x. So it's going to be negative 5 over 2, which is negative 2.5 squared. So I'm just going to write plus negative 2.5 squared. And then we go plus 9, take 2.5, negative 2.5 squared. Now it's actually really important that I don't simplify this part here. I don't need to simplify that because I know that's going to go straight into my bracket with the original squared term, so x, the term containing x, negative 5x, and the new squared term, that's going to form the perfect square, this bit in here. And the way it forms it is that we've now got, if you look at this, we've got a squared term, we've got another squared term, and then we've got a term inside here which is 2 times this square times that one, which is exactly the same as a perfect square here. So what this becomes actually is x take 2.5 all squared, and then we just simplify the rest. So that's going to be plus 9 take 2.5 squared, which is going to be 9 take 6.5. Now just be very careful, and even be very careful how you say it. That is minus 2.5 all squared. So this minus 2.5 has to be all squared, which means you're going to do minus 2.5 times minus 2.5, which is positive 6.5. But we're still taking away, so we're taking away a positive. So just be careful that you don't get tripped up there. So we get x take 2.5 all squared plus 9 take 6.5, which is going to be 2.5. And that's the answer. If you wanted to leave that as 5 over 2, that's fine. And often it's better to leave it as a fraction if we don't have a fraction which goes nicely to a decimal. So if we had like 2 1/3, that's more accurate than 2.33. Okay, so in that case you'd leave it as a fraction. In this one it's okay because 2.5 is actually the value of 5 over 2. Alright, you've got one more example on completing the squares, but that's something that you might be doing in class, or you can just try at home, and it's just to help you to see the links between all the different types of factorising we've talked about. Enjoy!